Ever get that feeling like you just hit a wall? No, not literally, of course, but just like metaphorically, like you've reached some kind of limit.
Yeah, I know that feeling.
Okay, so now imagine that, but like on a cosmic scale.
Okay.
So say you're in a spaceship
Gotcha.
and you've got like enough fuel to just burn for like eternity.
Okay.
And you set your sights on the most distant star you can even imagine.
Right.
Do you ever actually reach an end? Like, is there an edge to the universe?
Ooh, that's a good question.
Well, get ready to dive into that very question today as we explore the surprisingly knowable edge of the universe.
It's a question that's really captivated astronomers and philosophers, like, for centuries.
Yeah.
I mean, just think about it. If the universe really is infinite, just teeming with stars, why isn't the night sky just ablaze with light?
Yeah, it's true.
It's like, if you think about it, every line of sight should end in a star, right?
Right.
And it should be bright.
It should be like a sheet of light.
Exactly.
Yeah.
And that's actually the heart of something called Olber's paradox.
Okay.
It's this deceptively simple question that when you really start to unpack it, it hints at the mind-boggling nature of the cosmos.
We're already in head-scratching territory, and we haven't even like left the launch pad.
Yeah.
But before we get lost in like the vastness of it all, let's set the stage a little bit.
Okay.
So our understanding of the universe's edge, it's really rooted in the Big Bang, isn't it?
It really is. I mean, the Big Bang model, basically, it suggests that around 13.8 billion years ago, everything, and I mean everything we know,
Wow.
burst into existence from this incredibly dense and hot singularity. And here's the real kicker. The universe hasn't stopped expanding since.
Okay.
And we're not just talking about, galaxies just moving away from each other within space. It's like space itself is stretching. Like, imagine a cosmic balloon being inflated.
Okay. So that's where things start to feel a little bit like that scene in Alice in Wonderland, where like the room starts to grow.
Right.
But what really throws me is that the farther a galaxy is from us, the faster it's moving away from us.
Yeah.
Right? It's like the universe is playing some giant game of cosmic tag, and like the rules are constantly changing.
You got it. And that's exactly where this concept of the Hubble sphere comes into play. Now, it's really important to remember that the Hubble sphere, it isn't the actual edge of the universe, okay?
Okay.
It's more like our current observational limit. You see, light, it has a speed limit.
Right.
So the Hubble sphere, what it really marks is the distance from Earth where objects are moving away from us faster than the speed of light.
So anything beyond the Hubble sphere is just, poof, gone. Like it's lost in some cosmic void that we can never observe.
Well, it's not quite as simple as that. And this is where it gets really, really interesting. The Hubble sphere itself is actually expanding.
Okay.
So think about it like this, okay?
Okay.
Imagine a galaxy, but it's far, far away, like way outside our current Hubble sphere.
Gotcha.
And it's moving away from us, but faster than the speed of light.
Okay.
But as the universe expands, remember, the Hubble sphere, it's expanding too. It's like a cosmic game of catch-up. And eventually what happens is that Hubble sphere, it catches up to the light that the galaxy emitted, but like a long, long time ago.
So even though something might be moving away faster than the speed of light, we might still be able to see it eventually.
Eventually, exactly. It's like the universe's way of sending us a delayed message from the edge of what we thought was knowable.
That's incredible.
It really is. And speaking of seeing incredible things from the far reaches of space, I know you wanted to talk about the Hubble Deep Field.
Oh, absolutely. The Hubble Deep Field.
This image, it's captured by the Hubble Space Telescope.
It's amazing.
It's always just blown me away.
Yeah, it's one of those things that just, like, every time I see it, it makes me feel incredibly small.
Yeah.
Just completely insignificant. You know?
feel very small.
But also at the same time, completely in awe of just, like, how vast the universe is.
It really puts things in perspective, doesn't it?
It really does.
I mean, you're looking at essentially the edge of, well...
It's like, for those who haven't seen it, picture this.
Yeah.
You have the Hubble telescope, right? And they focused it on this tiny, tiny patch of sky. I mean, we're talking like seemingly empty to the naked eye.
Oh,
like
yeah.
You wouldn't even, if you're looking, you'd be like, there's nothing there.
Right.
But they focused on it for 10 days.
10 days?
And what it revealed it sent chills down the spines of astronomers. And it continues to captivate anyone who sees it, because in that one image, they captured thousands upon thousands of galaxies.
It's incredible.
Each one a swirling mass of billions of stars.
Each one a galaxy.
And it's just like a pinprick in the sky.
It really is. It's this tiny little, like, I think the analogy they use is like a grain of sand held at arm's length.
It's unbelievable. And you're right, it's a powerful reminder that what we see in our night sky, even with a telescope, is just the tiniest glimpse.
Absolutely.
It's like, what else is out there? Right?
Sure.
Hidden from our view.
It really makes you wonder.
It really does. It really makes you realize how much we don't know.
So much we don't know.
But it's not like we're totally clueless, though, right?
Right.
We have tools.
We do. We have tools.
Like analyzing redshift.
Yeah, redshift.
Which helps us decipher these cosmic mysteries.
Redshift's a big one.
So how does redshift actually help us make sense of a universe that seems intent on constantly expanding?
Okay, so redshift is like one of the most valuable tools in an astronomer's arsenal.
It's like their secret weapon.
It is. It is. And it's essentially like a cosmic combination of a speedometer and a time machine.
Whoa, okay.
All rolled into one.
Wow.
All right, so picture this, okay? So as light travels through the expanding universe, its wavelength, it actually gets stretched out.
Okay.
And this stretching, it shifts the light towards the red end of the spectrum.
Okay.
That's a very creative name, redshift.
Okay, so it's like as the universe stretches, the light stretches with it.
Exactly. Think of it kind of like the Doppler effect. Have you ever heard of that?
Yeah, like when a siren is going, and as it gets closer, the pitch gets higher, and as it goes away, it gets lower.
You got it. Same principle, just with the light waves instead of sound waves.
Yeah.
So the farther away an object is, the more its light has been stretched.
So the redder it appears.
The redder.
Yeah.
You got it.
And the faster it's moving away from us.
Precisely.
Like the universe is leaving us a trail of breadcrumbs.
It is. It's leaving us clues.
And we're just like trying to follow them. It's like Hansel and Gretel, but with like a telescope.
That's a good way to put it.
We're trying to piece together the story.
Exactly. The story of the universe's evolution.
It's like the ultimate cosmic detective story.
It really is.
But let's talk about like the shape of it all.
Okay, shape. Yeah.
I mean, we've been throwing around terms like expanding and stretching.
Yeah.
But what are we actually talking about when we talk about the shape of the universe?
That's a question that's, well, it's puzzled cosmologists for a long time.
Yeah.
Because, I mean, imagine if you could only walk in straight lines.
Okay.
And you were trying to figure out the shape of the Earth.
Oh.
It's really hard to do.
Yeah, that would be really tough.
But the good news is we actually have ways to probe the universe's geometry.
Okay.
And it all kind of boils down to this idea of, like, understanding the curvature of space-time.
Space-time. Okay, now that's where things get really, like, mind-bending for me.
Yeah.
It's like I always think about those, like, really cool graphics you see where it's like gravity is warping the fabric of space and time.
Exactly. And that's not far off, actually.
Okay.
Because Einstein's theory of general relativity, that's exactly what it tells us, that mass and energy, they don't just exist in space-time, they actually warp it. They bend it.
Okay.
And this bending, this curvature, it plays a huge role in figuring out, like, what is the overall shape of the universe?
Okay, so how do we even begin to measure that?
Well, to do this, cosmologists, they turn to something called the cosmic microwave background radiation.
Ah, yes. The cosmic microwave background, the afterglow of the Big Bang.
Exactly.
It's like looking at a baby picture of the universe.
I love that analogy. And you're right, because just like a baby picture, you know, it can reveal a lot about a person's features, you know, maybe even a little bit about their personality.
Right.
The cosmic microwave background, it holds all these subtle clues about the universe's, like, earliest moments.
Okay.
And it can even tell us about its overall geometry.
Wow.
And so by analyzing the patterns, like, within this radiation, cosmologists, they've actually made a pretty amazing discovery.
Yeah.
That the universe, at least on the grandest of scales, it appears to be flat.
Flat, so not a sphere, not like a saddle. Nope. Just flat.
As far as we can tell, flat.
I gotta be honest, that's not necessarily any easier to wrap my head around.
Yeah, it's a weird concept.
What does it even mean, like, for the universe to be flat?
Well, so one way to think about it is, in a flat universe, parallel lines, they would stay parallel forever.
Okay.
Theoretically.
Okay.
Now, this doesn't mean that the universe is shaped like, you know, a pancake or anything.
Okay, good to know.
Although that's a fun image. Right.
Right.
It could still be curved in ways that maybe we just can't detect yet.
Okay.
But from the largest scales that we can actually measure, all signs point to a flat universe.
Okay, so then we have this potentially infinite flat universe.
Yes.
That's constantly stretching and
Expanding.
And that's where we get to this whole idea of infinite use.
Ooh,
Which, I'll be honest, kind of blew my mind.
it's a weird one.
So are we really saying that there could be countless copies of ourselves out there in the cosmos?
Well, it's one of those strange things that comes out of, like, the idea of an infinite universe, right?
Okay.
So if the universe really is infinite,
Okay.
and there are only a certain number of ways to arrange matter,
Right.
then theoretically every possible combination, including like you and me, would have to repeat an infinite number of times.
So you're saying there's another me out there somewhere
Potentially, yeah.
recording a podcast about the edge of the universe?
Maybe, yeah.
Maybe one that's like a one-renowned astrophysicist?
It's possible.
Or like one that's a truly terrible singer but just doesn't know it?
There's an infinite number, so it could be out there.
Oh, man.
Yeah.
So no multiverse meet and greets in our future.
Probably not, no.
I have to say, I'm a little relieved. My schedule is pretty booked up.
Yeah, I get it.
But this idea that like the Hubble sphere acts as this shrinking bubble
Yeah.
that like limits what we can actually interact with, even in an infinite universe, it's kind of a sobering thought.
It is, because even though technically the Hubble sphere, it's growing, right?
Right.
The universe is expanding even faster.
Oh, wow.
It's accelerating.
So it's like we're losing the game.
Kind of, yeah. It's like trying to outrun the tide, you know?
Right.
No matter how fast you go, some things are just going to be lost to the waves.
Wow, that's a really powerful image.
Really?
The sense of like there's a boundary between what we can see and what's beyond.
Yeah.
And it's constantly shifting.
Constantly shifting, yeah, and not always in our favor.
So if we're losing sight of more and more of the universe, what does that mean for our understanding of it? It's almost like, we're on this cosmic ship ourselves.
Right.
And we're just watching the universe, kind of unfold outside our little porthole.
Yeah.
But knowing that, like some of that view, it's slipping away.
It's true.
And it makes you wonder, like, what's the point of an infinite universe?
Yeah.
If we can never actually see it all?
If we can never appreciate it all.
Yeah, and what happens to our understanding?
Right.
Like, what happens to our understanding of the cosmos when more and more of it becomes basically unknowable?
Yeah, it's definitely a bittersweet reality. Because you're right. I mean, as these galaxies, as they cross our cosmic event horizon, they're not only fading from view, but they're also becoming unreachable.
Yeah, it's kind of sad in a way.
It is kind of sad. Like, imagine future astronomers, right?
Yeah.
They're gazing up at the night sky, but all they can see are the stars of our own Milky Way.
Oh, wow.
That's a very different picture.
That's like a limited edition view.
Right.
But, limitations, they often breed creativity.
That's true.
So maybe this cosmic isolation,
Yeah.
this feeling of being like, confined to one galaxy,
Right.
maybe it would force those future astronomers
Yeah.
to approach the universe in like totally new ways.
I think you're absolutely right. Because without those distant galaxies to study,
Right.
without those cosmic breadcrumbs to follow, they'd have to get really creative. Yeah.
They'd have to squeeze every single bit of information
Yeah.
out of the one galaxy they have access to.
It's like they've been given this incredibly complex puzzle box.
Yes.
And they're told, this is it. This is all you have
Right.
to unlock the secrets of the universe.
I love that. What a challenge, right?
Yeah, but then again, humans, we have a knack for rising to the occasion.
We find a way.
Especially when there's a good mystery to be solved.
Especially a good mystery.
Right. And who knows what incredible discoveries are out there.
Exactly, because maybe
Yeah.
they'll develop technologies we can't even imagine right now.
Yeah.
That'll let them peer beyond that cosmic event horizon.
Oh, that would be amazing.
Right. Or maybe even uncover hidden dimensions or alternate realities.
Things that we can't even fathom today.
Things we haven't even thought of.
Right. Or maybe they'll just stumble on something, some piece of evidence that totally challenges our understanding of physics.
Oh, wow.
And we have to rewrite all the textbooks.
We have to start all over again.
Exactly.
Oh, man. Well, I have to say, for all we've learned, it feels like we are really just scratching the surface.
We are absolutely just scratching the surface.
That's something that's constantly expanding, constantly pushing those boundaries of what we thought was possible.
And that's the beauty of it, isn't it? It makes you wonder what is out there just beyond our reach.
It really does. The universe is infinite, ever expanding, and always full of surprises. And, speaking of surprises, we'll be back next week to dive into another cosmic mystery. So until then, keep those minds curious, and we'll see you next time.